Ooh, look at me, actually remembering to start the recording. Now, in case you haven't checked, after last class, what I did was I went back and I had all my MATLAB output that I could see, so I just made a new video based on that, and then spliced that with the 15 minutes of class that I actually recorded. So it's a video that's about half a time, so at least it's efficient. So at least I have affairs as much as I could get. Now, get the right font size going here. Okay, and what's the other thing I'm supposed to remember to do to start a class? Yes, at least if I'm active in MATLAB, which I will be today, not necessarily in general. Okay. Oh. Okay. Today's the 29th. Yes. Right. Now, if you remember quickly enough and you forgot to do that, then at least you can copy paste. Just that at some point, MATLAB's command window buffer gets exhausted. So, but the other thing that can help, if you forget, at least you can go back through your command history, start a diary, and then re-execute those commands. So there's ways to recover from that, as I've had to use when I forget to do that here. Okay. Now, one quick announcement I want to make. Okay. Might as well type that into the diary as well. Okay, because I mean, at least it's far easier to read than my writing, whether it's on the board or in Microsoft Paint. So the Siam Student Chapter meeting. So this is the student organization that I'm a faculty advisor for applied math goings-on at USM. So it will be held well before this class on Thursday, March 1st. And since I'm pretty sure that room 302 right across the hall is not in use during that time, that's where it'll be. So if you're able to show up a little bit before class, it's basically just an organizational meeting to try to get the ball rolling on, first of all, figuring out what activities we'd like to have during the coming year. Last year, the main activity was a career panel that was run in the spring. And also, we had a lot of members graduate. And this organization is meant to include both undergraduate and graduate students. And we had so many people leave. So all of a sudden, wow, our mailing list shrunk to half its size. So we'd like to try to reload, but also by having activities that people would be interested in. And also about Siam, this is siam.org. Let's see. And so there's a lot of information there about applied math in general. I have a whole lot of conferences that I attend and some students attend. And also there's a section here for students, a lot of resources for students. For instance, information about career paths, about student chapters and what they do, and so on. So we're the only Siam student chapter in Mississippi. We beat Ole Miss and State to a punch. Ha. And we've had chance for students to go to some conferences because we have some alumni that help us pay for those things. Okay, so if you can stop by, or if you're not able to go, but would still like to find out more about what your chapter is doing, maybe you could take part in some of his activities during the year, then you can just let me know. Okay, and as I mentioned before, there's a flyer across the hall that has a chapter's email address, so you can use that to get on the list yourself and keep up with what's going on. Okay, now, all right. So what I'm hoping is that all of you have dived into homework 1 and made at least some progress with that, at least to the point where you have questions you can fill the time with. So how's that going for everybody? Okay. All right. Well, Kristen, I saw your hand first, so.
Number 13, I guess I'm just not really sure.
Okay.
Because, like, it's the one with the upper matrix, and when you do the matrix in MATLAB, like, you can't get it all on one line at all, so it's really hard to look at it and analyze it in any way. So
Okay.
I don't know if there's a way to change that out.
Whoops. Okay, number 13. Okay. All right. So, all right. So what I'm going to do is I'm going to produce a matrix that looks like that one, but I'm not going to type in all this because I want to take kind of time. But there's a way to get this kind of matrix by well, actually, no. I'll have to do a little bit less cheating to produce the same effect. Okay. So if I make a random matrix 40 by 40, and keep in mind, only one argument to rand is if you do that, it assumes you want a square matrix, that number of rows and columns. And as you can see, when I display such a matrix, okay, I'm going to use format short here. Yeah, there's a lot of output here that's groups by columns, and this is why it's important to remember to have your diary going before you do too much. So now, if I'm going to run this command, lu of a, which has the effect of carrying out Gaussian elimination. So the matrix U that is produced is going to be, so in 326 terms, if you reduced A to row echelon form, which is what this script does, then U is the matrix that you get. So now I'll take a look at U, and so here we can only see the last 5 columns, and if I scroll up, then I can see more. And this is freaky. What?
I was just going to say it's hard to analyze the matrix when you look at it like that.
Yeah, and actually, I think what MATLAB did here is it actually explicitly sets these entries equal to 0, which is not what I wanted. Okay, hold on. I believe I should have, if I type what, that will list all the files that I have. And the file that I actually want is not here. Okay. I'm sure I have this somewhere. Okay. Ah, I do. Okay. Oh, I have it in this directory also. Okay, that's good. Okay, actually, I don't want that one either. If I use when I did this, it found it in a different directory, and I didn't want that. So if I do /, then I'm referring to a file that's actually in this directory, not somewhere else it might find it. Okay, and now it's blank, which is what I intended. And now so now I have the same code that you're running. One thing, this is sort of an anachronism of MATLAB. Ages ago, like I've been using MATLAB for 26 years. You had to back in the old days, you had to put a comma here. You don't have to do that anymore. It's not a big deal whether it's there or not, but it gives you a warning that you don't need that there. Okay, so now if I go ahead and run this, okay, so now I have the same kind of matrix A that you're dealing with. Now, as for what it's asking, examine this matrix U. And when I say examine, I just really mean just eyeballing it. And as for a question, why are some subdiagonal entries non-zero? And what I mean by that is, so for this problem, I recommend going to the first columns. So after elimination. And what row echelon form is supposed to be, you may remember from linear algebra, or 326, is that all the entries below the diagonal are supposed to be 0. And what you see here is you have a sea of zeros, but notice there's a difference. You have or just a digit 0 by itself, and then you have 0.000, and then you have minus 0.000. And you're thinking, why? That's really what the focus of this question is. What is the distinction between an entry like this one, and I'm highlighting here, or this one, or this one? Now, so now what I'm going to do is I'm going to change to format long and see if that reveals anything. Okay, so format long, and if I just go ahead and display A again, now it's going to be more of a pain to scroll up to where the entries of interest are in these first columns. Okay. So here we see the same thing, only with more decimal places. Although as I was scrolling by, I noticed something in a later column. See if I can. Hopefully, I wasn't imagining things. Here we go. Here we have something that's almost 0. It's pretty dang small. Minus 0.0004, and then you see the last digits of these other numbers here. Also, we see some non-zero values. And but the vast majority of the entries are, at least what it displays, is actually 0. So here's what you can do: is you can then have MATLAB display for you any one of these entries individually. For example, this entry right here, that is in column 1, and that is in row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the entry that I've highlighted here, that's row 10, column 1. So I want to take a look at that one by itself. So I can just do that. And sure enough, it's a pretty small number. So minus 2.8 times 10 to the minus 17, which is why earlier it showed it as 0.00000 whatever. Whereas the entry above that, so row 9, it just displayed it as just the digit 0 by itself. And so this is sort of foreshadowing one of the next topics, and that is floating point arithmetic. But even in chapter 1, so at the section 1.1, there's some discussion of the different kinds of error that you can get. So really, what I'm looking for you to at least speculate about is what's the difference between this entry and this entry? Why is it that if the intent of Gaussian elimination is to make all of the subdiagonal entries equal to 0, how come we are getting 0 in some cases and not in others? So that's something for you to think about. Does that answer? Okay. All right. Okay, more? We got time. Yeah. Oh, did you have a question earlier? Okay. All right. First come, first serve. Yeah. What?
For number 11, are we allowed, when we're trying to figure out which matrices are supposed to give you, it says, just supply the definition by finding a non-zero vector x such that is -0 imaginary. Can we put imaginaries in that x?
Oh yeah, you can put whatever you need to in there to create the desired effect. Okay.
And jumping off of that same question,
Yeah.
do you want us to explain why the answer is that, or just answer with the matrix? Do we have to elaborate?
Well, just work it out. I mean, yeah, because I mean, you're performing a well-defined operation. I think that's what comes out. Yeah.
Need to put that in the code, or just do it by hand.
Oh, however you want to do it. Yeah, yeah. Carly.
I have script questions.
Okay.
So I think the first one's number 12.
Right.
How do you want us to format the script into the diary, and how do you? I don't even know how to start a script.
Oh,
Well, I guess if I do you
Okay.
want it just into the diary?
Well, thing is, since the script is going in an M file, now, do you have a problem with that too, or?
Well, the way I did it was I did like a diary, how we did the text file in the end.
Yeah.
I named my script and I did .m. Does that automatically make it a script?
Yeah, any file with .m is considered either a script or a function, depending on whether the first word is function or not. Now, okay, so here's what I would suggest is, okay, don't make your diary an M file, because diary is containing the commands which may include running scripts, or actually they will include running scripts, and the output they generate. So as far as creating a script, this is the easiest way to do it. It's just edit and then the name of a script. Did you do something like this already? Okay. So then, now the thing is, I already have content in here, but this is where you would type it. And then, so after you have all this in here, and then when I run the script, okay. Okay, so there's where your script content goes. And then to run the script, typing its file name at the prompt. So this, everything I'm typing here is that's what's going to go into your diary, including all this output. Yeah. And okay, now then for submission purposes, you would submit your diary, like your .txt, whatever, and your script as separate files.
And there would be multiple scripts in one diary.
Right. Well, if it ends up being multiple diaries, I don't really care, but whatever happens, yeah. Okay. Yeah, this particular assignment is going to have a handful of scripts and even also some M files that are functions toward the end. Yes.
Do you want us to just put our name in the script so that you know, in the M file, so that you know that it's
That'd be a good idea. Just yeah, because what I'm going to do is when I get your submissions, I'm just going to create a separate folders for each of you and dump all your stuff in there. But yeah, I mean it's a good idea. You never know. I sometimes lose paper assignments, even with files. You never know. Can't trust me. Okay. All right. More? Or do you have another question? Or? Okay. All right.
I just don't like how MATLAB looks.
Oh. Okay.
Sorry.
No. Now you make me curious. Like, what exactly?
I've just been doing, I don't know, like C++ and other ones.
like you can't edit in the
Yeah, like
line.
MATLAB's just weird.
Oh.
With C++, you can edit like in all in one thing, and it's something like that.
Yeah.
There's so many like like you go into other windows and then I'll have like 10 windows up.
Yeah. Well. Okay. So for instance, when you were working in C++, was it like in Windows or Unix environment, or like what software were you using?
I was using dev, C++ dev, DEV or something like that.
Okay. Yeah.
It was in Windows.
What? So it's not like Microsoft Visual Studio or anything.
I use Visual Studio too.
Right. Okay. Yeah, because a lot of times, whatever the language, people are always making these like IDEs, integrated development environments, which this is meant to be for MATLAB also. Um, but yeah, that wasn't even the way I learned to program because back then, actually, when I learned to program, Windows didn't exist yet, um, and we did everything from a command line. So I don't know if you were doing a lot of command line type things. Um, uh, like for instance, just uh, doing whatever from a terminal window.
Yeah.
Yeah, and I, I still like to work away. Like for instance, when I'm working on the websites for my classes, that's what I do. Uh, well, actually, I could show you that now. Um, like so now this is just HTML, but the thing is, I'm doing everything here from a command line, like to edit the web pages, like if I want to change the due dates or things like that. And so you're probably doing something similar where you're just compiling, editing, running from this kind of setting, right? Now, one thing I'm curious about, if I go back to a local environment from a Mac, oh, what? Oh, what about that?
I don't know if it's a program or a language.
Beaver?
Beaver.
Um, hmm.
It's what my internship made me use.
Oh, okay. For what task exactly?
Data analysis.
Oh, okay. That I'm not familiar with. Yeah. Was it kind of like R?
It was more like C++, but I don't know really what R looks like that well, but they were saying it was kind of like R.
Okay. Well, yeah, because R is kind of a development environment, but also a language, and Beaver might be as well. Yeah. Um, okay. Ah. Um, yeah. Here I've launched MATLAB from a command line. So what I could do is if I were to open up another terminal window. Okay. Now if I look and see what directory I'm in. Okay, so my home directory. Um, okay, so now if I go to that same directory here, documents, MATLAB, Math460, and I can enter, I can, like, for instance, edit my script here and then run it here. So for those who like command line environments, it's certainly possible. But yeah, I can't blame you for not being a fan of this kind of environment, and sometimes it does think. Oh yeah. Well, what it reminds me of, like what you're experiencing is, yeah, I learned all my programming as an undergrad doing the command line environments and also using Emacs. Has anyone even heard of Emacs? No. Okay, that shows how much of a relic I am. But it's freaking amazing. So, um, and then years later, when I get my first software job, I was a software engineer from 1996 until 2002, and good riddance. Um, and it and that the companies worked with were using Microsoft Visual Studio, and and that environment's like, this is way too weird because they took a lot of things out of a developer's hands. They have all these files they equip you with, and then like, well, where do I type my actual code? I'm accustomed to doing everything, and it just uh, and I find it's better if I have more control over the process. I mean, it's nice to have certain things done for you, but it can also be unsettling. Um, and those of you who may be considering, well, I mean, we have mostly, not entirely, but mostly math majors in this room, and also the other two rooms or class meets, and uh, certainly having any kind of programming experience makes you more employable. and that's what I could get to. For instance, software jobs, they pay really well, and they are, I don't know, I was absolutely miserable. So it was only the paycheck that kept me there as long as it did. Okay, so all right, now, but please tell me if there are any other questions from anybody about. Yes.
I have a really technical question.
Okay.
Since you're using a Mac now, correct?
Yes.
Is there a way to execute one line from a script using just the keyboard?
Okay. So wait, one line from a script. Okay.
If I'm like in a script, it's like you can run sections and stuff like that, like just to
Right. Oh, I see. Like, now you might be thinking of, like, for instance, using the debugger, but we're able to set breakpoints and have it proceed like in a line-by-line fashion.
It's just I'll get really accustomed to like an arc, like that's how I would check it. Is like go line by line, just check.
Okay, yeah. That does sound like a really nice feature. No, what I do in MATLAB is, if I'm trying to zero in on wherever a problem is, I might comment out certain things, just to try to isolate the problem, or have it print things along the way. And I assume like this is what you were asking me about before class, and because in this case, really, it's not so much a matter of like what's happening on a particular line, but how things flow. Like for instance, okay, and this actually kind of goes to your question, but like flow control statements, like if statements, while loops, for loops. If we look at enter month year, and the funny thing is that as mathematicians, we're very accustomed to following step-by-step procedures to solve whatever problems, but at some point it becomes so innate to us that when we have to use a similar kind of thinking in figuring out why our programs are not working, it's not. You think it would be the same thing, but it doesn't feel that way in terms of how your data changes as you go through executing all the statements of this program. For instance, keeping in mind that as I enter, if I have a user enter a month and a year, and then check, okay, if a month is 2, then do these things. Otherwise, I'm going down here, and then it's checking if any of these things are true. If none of these things are true either, then I go down here. So one thing that'd be a good idea to, if you have code with if statements and you're trying to figure out why it's not working, maybe make some notes as to if you're at a certain point in the code, what things are true or false in order to get to that point in the first place. For instance, I'm only going to be here if the month I was entered is 2. But if I get to this point, so referring to the statement down below, the month is not 2. So that's something I'm keeping in mind as I write the if statement, because you wouldn't be here if the month was equal to 2. I wouldn't be here because the month is not 2 or any of these others, 4, 6, 9, 11. And now, this statement here, it's taking the month name that we have from before, the year that the user entered, also the days. So days, the variable days, has to have a value by the time we get to this point. This is where else statements are very important. If month is 2, this is done. If month is 4, 6, 9, or 11, this is done. If month is anything else, so this else, this is very important, is your catch-all. At least you make sure that days has a value. In this case, so I take care of all the exceptional cases, and then the default case, well, most months have 31 days. So I'm putting that here. So at least this way, guarantees that days is assigned something. Since I'm putting comments here, I'm going to post this on the site after class under the entry for today, so you can see what I typed in here. It may not be a matter of just one statement, but just the flow of data for your code. When this code, or any code that has if statements or for loops or while loops, is compiled and run, the way this is implemented under the hood, like in actual machine language, is literally to jump from one statement to another. So you could be executing some statements sequentially, and then bam, you go to another statement that's far away. Like for instance, when in this if statement, there's a comparison to check if month is equal to 2. If month is equal to 2, it's just going to go to the next statement. But otherwise, there's going to be a jump to tell it to go down here and continue with the next conditions and so forth until all conditions are exhausted. If one of them are true, let's suppose the month is equal to 6. So we check this condition, it's false. Then we move to the next condition, it's true. Then we execute this code. After days is set to 30, there's going to be another jump to skip over this and then continue with the following statements. So this is the kind of behavior of if statements that's important to be aware of. And unless someone has a question right now about this or anything else, but okay. I'm going to quickly cook up an example to explain what I mean about how we have to be careful with if statements. So I'm going to make another script. I'll put this on the site later too. Actually, I might do more of one kind of statement in this script. Okay. So I'm to have something to work with here. I'm going to make a random number x. So we know that x is between 0 and 1 just from the behavior of a random function. Okay, so I'm going to dang it. Hello? Okay. 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 I don't know why that. Okay. Get some more thumbs today. All right. So now we have 3 if statements, and then I'm going to make this a little bigger. I'm going to copy these and make a little change here. All right. Now, okay. So I'm going to go ahead and run this script. Well, I'm going to take out a semicolon here because I want to be able to see what value of x was generated. Okay. And I also want to have a statement here, or have a little text to separate statement 1 from statement 2. Actually, I'm going to make this an else if also. Okay. Now, so I'll just type the name of the script to run it. Okay. Wow. I really didn't expect to get an x that was this close to 1. And here we see the same behavior. So right now there's no reason to believe that the behavior of the if statements, although they are different, is expected to be any different. But now if I run this again to generate a different x, and it seems to be biased in favor of producing large x's, and it's going to start to annoy me if it keeps doing that. Okay. Now, I want to get something that's... Okay, so notice here it didn't print out anything. So, well, why is that? Because x is roughly 0.84 something. So none of these, all these relied on a condition of some kind, being less than a half or less than 0.1 or greater than 0.9, but none of those were ever true. So there was nothing to print. Now, if I'm going to keep running this until I get an x that is, in the words of my if statements, really, really small. But apparently it's, oh, what a tease. It was really close here. Okay. And yet it's seemingly biased towards, towards larger values. A lot of cases where it's not printing out anything. Here we go. So, see, we have different behavior here. That first time prints out 2 statements. The second time it only prints out 1, and not the one that I really wanted, because this value is really small. So if we take a look back at the script, okay, so the first time out, if whichever one of these apply, these are all separate if statements. So this particular x being 0.07 is going to satisfy 2 of these, so 2 things are printed out. Because they're separate statements, all these conditions are going to be at least checked. Whereas the second time around, okay, x is less than 1/2 because it's only 0.07, so it prints out this, and then it skips everything else. It might have been more logical for me to have these in reverse order, like if I put this one first, because that's the most condition that best applies to such a small value, and then do something like this. So if it's really small, prints this out. I mean, if it's moderately small, it'll print this statement if it's less than 1/2. Otherwise, if it's particularly big, then it'll print this statement. But we saw that a lot of times it produced values like 0.6 or 0.7, and nothing was printed. Well, chances are you don't really want that. So anything else is... So this statement is always going to print something. So for expiration 13 for day and year, you're going to have something printed at the end. So you have to make sure that your if statements are structured in a way that there's always some value assigned. So if you're having trouble getting statements like these to work, then you basically need to execute them in your head. Like for a particular value of x, or if you know what x is, what will happen under these circumstances, and that's often what leads you to figure out what's wrong. The other thing that I can pretty much guarantee you is that when you have, the longer it takes to find a problem in your code, the harder you want to kick yourself when you finally figure out what it is. Because it's something, it's almost always something little, that produces behavior that you never could have expected. It just seems to turn out that way. And when it happens to me, it's like I tell myself, okay, I know I'm going to be really embarrassed when I finally find this thing. But, yeah, so part of the experience. Okay. All right. Yeah, and there's 2 schools of thought when it comes to finding bugs like this. Like some people like to use whatever debuggers. MATLAB does have a pretty nice debugger that you could take using the like run in advance. It lets you run current sections in advance to run your code in sections. And I tend to use debugging approaches that work well no matter what language you're using in, because I'm not always familiar with facilities that any language offers, like having it print things out or commenting out sections of code that I don't want to deal with, things like that. And that seems to serve me well too. Now, out of curiosity, has anyone gotten as far as exploration? Let's see, we're 25 altogether. So, like up to the last part where there's graphing involved? No. Okay. Now, actually, I'll take a look at what's ahead, but feel free to chime in with questions on any others. Okay, so at least we know that some people have gotten up to this point. Actually, one preemptive discussion of this one, number 14, number 14 and 15 are similar in nature, where you're writing some script, and so I'm going to, and if you're using, here I'm using Adobe Reader to go through the textbook. So not all PDF readers might be like this, but when I have references to other sections, those are clickable. Now, of course, now I have to find my way back, but so that could be a problem. But so, for instance, I'm going to give you a skeleton of sorts. What I have in mind for number 14, and then number 15 would be similar. Okay. C equals A plus B. So the formula from a textbook is the definition of matrix addition. You're just adding your matrices entry-wise. So C, I'm using underscore to indicate subscripts. Equals Aij plus Bij. Now, the point of this exploration 14 and also 15 is for practice using for loops. So for Cij, for I and j equal, well, I going from 1 to m, and j going from 1 to n, where a and b are m by n, so the generic matrix size. Now, one thing I want to point out, so without discussing the for loops, because that's the part that I really want you to do, but so the for loops will have a similar form to what you see if I go back. To where Gaussian elimination was. So something like this. Like here we have typical for loops. So you want like I going from 1 to m and j going from 1 to n, and then computing and using this notation to access individual elements of matrices. Okay. All right. In order to perform the addition. So the other thing I want to mention is to get the size of A and B. So for instance, m and n would be the size of A. So m is equal to the number of rows, n is equal to the number of columns. But for the purpose of this script, like this would be a case if you were given the matrices A and B already, and we have to assume that A and B are the same size, because that's what's required for addition. Or you just make everything up, and this will be fine for the purpose of the assignment. I'll just make up values for m and n, and then make a random matrix of that size, and then similar for B, and then work with that. So then to fill in entries of C. So this is the part that I'm going to leave to you. Now, B must have the same size as A for addition, whereas for multiplication, they don't have to be the same size, but they have to have compatible sizes. That if you're multiplying A times B, the number of columns in A must equal the number of rows in B. But the other dimensions can be whatever. Now, one thing I want to mention is for best performance, pre-allocate C. This is something that is not required, but it's a good idea anyway. In this case, since A and B are m by n, if you fill in entries, start C off as a matrix of 0 entries of the same size, and then you can have your for loops that actually assign the values to those entries from the addition. Now, if I do not have this here, and you fill in your for loops correctly, your code will still run. You won't even notice a difference. However, MATLAB's going to give you a warning in your loops when you're filling in the entries of C, saying that the size of C is changing every iteration. Consider pre-allocating for speed. Because here's what would happen if I make my loops to fill in the entries of C, and if I did not do this, if I did not pre-allocate. What would happen is you fill in the 1 entry. So MATLAB allocates memory space for one entry and fills number in. Then you go to the next entry, like the 2-1 entry or the 1-2 entry, depending on how you have your loops done. It's going to deallocate C that has 1 entry and then reallocate to have 2 entries. And it's going to keep doing that every single iteration. It's going to deallocate what was already there for C because it's found out it's the wrong size, and then reallocate at the larger size every single time. And that creates a serious drag on performance when you start dealing with larger vectors and matrices. So I make sure to avoid situations like this. I always pre-allocate my vectors and matrices, even if it's not absolutely essential, because when you're dealing with larger scale problems, you notice the difference in terms of speed, because you don't want to have MATLAB continually allocating and deallocating and reallocating like that. It takes time. So even though the number of arithmetic operations would not change, the memory operations that changes in a big way. Another thing I want to call my attention to, here we see M and N highlighted, and there's a little orange thing out here indicating a warning. And the reason why is if I hover over the M and it says you have a value assigned here to M appears to be unused. And the reason why is I give M a value here, and then right below I set it to something else. So watch out for those warnings. It may be something significant where you need to fix something, or maybe you're doing something that's unnecessary. The thing that MATLAB most often gives warnings about are variables that are unused. So in fact, I'll just comment this out. So then the warning is going to go away. And now let's go back to greens, because now I have no warnings. Okay. All right. So for exercises 14 and 15, you would one way or another create matrices of whatever size. I don't really care. And then you put your for loops. So you need 2 for loops to handle addition, and then you would need 3 for loops to handle multiplication, because you have to fill in the entry ij of a product C, but each entry is going to require a loop. Because if you look at the matrix multiplication, okay, so this is a formula for the ij entry of a product. So you carried out this kind of matrix multiplication in your linear algebra class, I presume. But to compute each entry, we're having to sum up all of these. So that's why you're going to need 3 loops nested within each other. So then what you can do, you can try this on some matrices that are small. And like for instance, if you can just type in simple matrices at the prompt, like having nice entries like integers, carry out the multiplication yourself, and then run your code and make sure that your code is producing a correct result. Okay. So any questions about that one? Okay. As I take a look at any other things, look for things to point out. But one thing I want to warn you about is, so starting, so on Thursday, I'm going to start the next topics. I get into chapter 2. Now, if you guys have questions about this homework for Thursday, I will allow time in class to answer them. But I'm also going to assign the chapter 2 homework. The chapter is ready, it's on the site, and there are a ton of problems in that chapter because, well, I'll just, because in chapter 2, there are the same kind of explorations, like for this assignment, but also at the end of every section, I have a concept check. These are short answer questions. This is all done on paper. Basically, it's a check to, did you actually read the thing? And have some understanding of what's in it. It's like definitions, things like that. In other words, not difficult, provided you did the legwork up front. So there's at the end of every section, and then this chapter has only 2 sections in it. First about error analysis, and then okay, so then there's another concept checked about the second section, floating point arithmetic, and then I have some exercises at the end. So if I were to add this up, let's see, and those of you who've taken modern algebra, especially if Dr. Cole, know about true or false with reasons. Oh, okay. So it doesn't matter what semester you take it. Okay. Okay. Yeah. Well, yeah, because that's what the textbook has. Yeah, they're. I would hope that mine are not as annoying as ones in modern, but because I've no desire for this class to displace modern algebra or real analysis as the hardest class in the curriculum. Okay, so 19 and 15 is 32, and then 14 is 46. Okay, so there are a grand total of, between explorations, concept check, and exercises, there are a grand total of 65 problems in this chapter. Now, I'm not going to assign all of them. Okay, I want to get that straight. Like the exercise, I think I'm only going to give like the first 5 or 6. But the point, and then I'll look for the exploration and see if there's any of those I want to cut out too. But if you look at the calendar, yeah. So you have a fair amount of time. But what should you do? Start early. You guys ignored my advice for this first one, and I'm still pissed about that. Don't do it again. Because if you look at all these things, you don't know how long it's going to take you. You don't have any way of judging that until you jump in. So don't wait till the last minute. And the idea is that while this is being covered, that you can ask questions either in class or by shooting me an email. Now, one of the reasons I'm giving until the 19th is that during the 12th and 14th, I won't be here. I'll be at a Siam conference in Germany. And I... What? Oh. Okay. Well, at least I won't be driving, so. Yeah. Okay. So, thanks for your advice. And and then I'll be getting somebody to substitute. We'll see who. I might not get my first choice, but well, actually, yes, subbing tends to not go well in my classes, but as some of you already know. Okay, and it's a good thing if they show up. Okay. So that's one reason why I'm giving you this much time. But I mean, with this doing the 31st, if you need a little more time, that's okay. I mean, I can be pretty lenient or sometimes outrageously lenient about deadlines. But since there is more coming, by the time we get into next week, after Labor Day, we have Thursday and then that whole week to spend on that chapter. I want you guys to have at least gotten a start. Read through sections, get those concept check ones out of the way, because every other chapter besides chapter 1 is going to have them. And bring your questions. Show that. Because the point here is not for me to cover every little thing. In fact, there isn't time for that. It's incumbent on you guys to dig into this beforehand, see what parts you can understand. We'll clean up the mess when we're here. So, and it's very important that I know you're not used to doing this in other classes, but your cooperation is essential. So don't piss me off again. So, so when I say get started, you need to get started. Okay. Now, for the problems that you have immediately ahead of you. So we've had some discussion of everything up to number 15. If you think of any other questions, feel free to shout it out while we still have time. Okay. So then after that comes while loops. So you can think of it as a for loop that runs for an indefinite number of iterations. So in fact, this is set up to be an infinite loop, but it will exit if this condition is satisfied. Otherwise, the loop literally would run forever if allowed to. And this is actually a preview of one of the last topics of the course, actually the last topic, Newton's method for computing roots. This code computes the square root of 2. Okay, and okay, so the way a while loop works is you have while and then some condition. As soon as the condition becomes false, the loop will terminate. So as long as the condition is true, the loop will keep running. So one of the explorations is about modifying this code so that instead of having a condition that's always true, you can have some condition based on this condition to have the loop exit. So instead of having an if statement in here, you can have your condition up here, but you'd have to make sure that the loop will at least run and perform a computation, because if you're running these statements starting in sequence, you get down to this point and the condition that you have here, whatever condition it is false, the loop will not run at all. So that's something to keep in mind. Okay. So really, your while loop, so for exploration number 16, the condition that you want to use, so that part I feel comfortable giving away, is, it's already given away in the problem. Use the condition that's given in the if statement. So you would have while this condition goes up here in place of the true, but then you have to make sure that the code still actually works when you run it that way. Because you have to make sure that any variables in the condition are actually defined, and then that it'll evaluate the condition and determine that it's true. Oh, wait a minute. No, I need this condition to be false. So, okay. Now I'm really glad I called attention to this problem because, yeah. The while statement must use, I should say, the opposite of this condition, because the condition in the if statement is a condition for leaving a loop. The condition that goes up here is a condition for continuing a loop. So So instead of saying greater than, you want or less than, you want to have greater than or equal to. So I'll fix this in the problem. So whoops. Of course, now I can't list myself in the acknowledgement since I caught the mistake, but oh well. Okay, so so for number 16, actually I want to. Okay, if I have that code here, Newton square root. Okay, I don't have it, but I probably have it in my file somewhere. I would think. Ah, okay, I have it somewhere. Well, not that one. Yes. Okay. All right, so what I'm going to do is I'm going to comment this out. And so the opposite of this condition is what goes in here. Okay. So this is for exploration 16. Make this work. And what's essential is an condition must be defined. EPS is predefined, so you don't need to worry about that one. It already has a value. Also, the values must be set in such a way that this condition, the loop will actually run. Okay, so I'll put this on the site also. So that's a starter for number 16. And then number 17 is a modification of that. You modify it again to have another condition where the loop will run a maximum number of iterations. Because sometimes these iterations can go on for a long time. You don't really want that. So we're going to limit it to 10 iterations, which actually for this task will be enough. And I explained how to have a while statement with an and in it. So if you have condition 1 and condition 2, use a double ampersand, which is the same as in C to make that happen. From this point on, you're generating M files that are functions rather than scripts. So this is your first function M file that just does a temperature conversion from Fahrenheit to Celsius. So for instance, if I were to copy this, and I'll show you how this function is run. This is something that you'll be doing as you go through the tutorial. Fahrenheit to Celsius.m. Okay, so I'll go ahead and paste that in here. So now I have my function. So if I want to call this function, I can have fa to cell. So I'll put in a Fahrenheit temperature of 212, and then it'll so that 212 is copied. That value is copied into. Get rid of that. Into a variable TF. That's the Fahrenheit temperature. The computation is performed to get the Celsius result TC. That is returned. And out here, that value 100 is stored in the variable answer because I didn't assign this to anything. Now, instead, I could have assigned it a value, and now TC has 100. But I could have called this whatever I wanted. Now, this function has one input and one output. Now, if I forget my input, if I don't specify an argument, it's going to complain that there's not enough input arguments, because that one is required. Or if I put in too many, it's going to complain for that reason also. And same is true for output arguments. Here I have one output. Here's how you accept multiple outputs. They're put in a list enclosed in square brackets. But this function only has one output, so it's going to complain. But other functions that you'll see later in this chapter have multiple outputs. And how to and there's also possible to make certain inputs or outputs optional, and that'll be discussed also. So that's a basic idea of how a function works and how you call functions. So the way you call functions is just like any built-in MATLAB functions. Because a lot of the built-in MATLAB functions, those are also M files. It's just that MATLAB provided them instead of you. Okay. Okay. So here you're writing your own functions, like sine and cosine work in radians. MATLAB provides sine d and cos d that work in degrees, but you know how to convert between radians and degrees. So you can write your own versions of sine d and cos d to do the same thing, piggybacking on sine and cosine. Okay. So sine and cosine, the input and output are, or the input angle is a radian. So you just have to make sure that if you're dealing with the input that's in degrees, then you convert. And then there's some other functions that are used as examples. And then exploration 19, you're not really writing any code, but just seeing how functions behave with different inputs and outputs, or different numbers of inputs and outputs, which is kind of like what I was just doing, to give you an idea. And then the last part deals with graphics, using these graphics commands to produce this plot. Okay, and then working with polynomial functions that'll be very useful to us throughout the course. And then what do you do for the exploration, printing out day and year, where you're modifying enter month year? You're going to modify that again for a very last exercise, 25, that indicates what day of a week a certain date was on. So what he did in number 13, I believe it was, to figure out the day within a year, that's going to be helpful for this. Because this exercise, yes, it's a pain. So I thought I'd break it down into 2 stages. Okay, so we're just about out of time, but so sure there are no more questions at this point about anything MATLAB, or from a course for that matter. Okay, because so some of you have gotten to around the halfway point, or maybe a little bit past that. So that means you still have a ways to go. So so you better get cracking. So be sure to email me with any questions that you might have. We'll have I'll answer any questions that you have on Thursday as well. But at the same time, I do want to get started on the next topic. So get cracking. Okay, so that's all for today, and I'll get this stuff posted.